So we are on the topic of differentiation. Internet connection is unstable, so my video is stopping. All right. So differentiation. Yesterday we discussed the first case, which was in simpler terms, if y is equals to ex, then dy over dx is also ex. However, if y is equals to e and instead of x there's a function of x in the power, then dy over dx is e power fx times f prime x. Also, we touched upon the concept from AS as well, that in we did this formula in AS that if y is equals to x power n, then dy over dx equals nx n minus 1. However, if instead of x, there's a function of f and it has a power n, then its derivative is n comes down, fx stays in the bracket. As it is, its power gets reduced by 1, and then you multiply the derivative of fx outside. This is what we studied yesterday. Today, we're going to study the second case, which is in simpler terms, if y is equals to natural log of x, then dy over dx is 1 upon x. However, if y is equals to ln fx, then dy over dx would be 1 upon fx times f prime x. Okay. Let's take a look at a few examples. We have y equals ln 2x minus 1. So then, derivative is going to be 1 upon 2x minus 1 times the derivative of this fx. So the derivative of 2x minus 1 is 2. So times 2. So the final answer will be 2 upon 2x minus 1. Another example is y equals ln bracket x square minus 5x plus 1. Then dy over dx would be 1 upon fx, so x square minus 5x plus 1 in the denominator, and you multiply the derivative of this with your answer, so that would be 2x minus 5. Two x minus 5. So the answer is going to be 2x minus 5 in the numerator and x square minus 5x plus 1 in the denominator. Another example. Y equals ln bracket 3 e power 2x plus 5. So then dy over dx would be 1 upon fx, which is 1 over 3 e power 2x plus 5 times the derivative of this. The derivative of this. So the derivative of this is going to be 3 the derivative of e2x, e power 2x is still e power 2x, but since this is fx and not just x, we multiply its derivative as well, which is 2, and then plus 0. So we have 6 e to the power 2x in the numerator upon 3 e power 2x plus 5. Can you guys hear me fine? Because Zoom is continuously giving me warning of bad internet connectivity.
सही आ रही आवाज.
Okay, ठीक है. All right. Another example question. Y equals, there's a bracket. The bracket has power 3, and inside there is ln 5x. Okay. Now, this is the case of y equals fx power n. And what's the derivative of that? It's n and then fx with power n minus 1 times f prime x. So this is what we have to do. So bring the power down, 3 bracket ln 5x bracket close square times the derivative of ln 5x. Sorry. The derivative of this. So what's the derivative of ln 5x? It's 1 over 5x and then multiplied by the derivative of this, which is 5. So it's actually 5 over 5x, which is just 1 over x. So times 1 over x. So the final answer would be 3 upon x bracket ln 5x whole power cube. Oh, sorry, whole square. ln 5x whole square. Another question. Y equals ln 1 over 1, 3x plus 1. Oh. One way of doing it is, it would be 1 upon fx first. So 1 upon 3x plus 1, because fx goes in the denominator, ln fx. And if we're derivating that, it's 1 over fx times f prime x. So it's 1 over 1 upon 3x plus 1. And now we have to derivate 3x plus 1. 1 over 3x plus 1. So what's the derivative of 1 over 3x plus 1? The 3x plus 1 goes up. So instead we can write it as 3x plus 1 whole power minus 1, and the derivative of this would be minus 1 comes down, 3x plus 1 whole power minus 2, and then multiply the derivative of 3x plus 1 again, which is times 3. So it's going to be minus 3x plus 1 power minus 2. So multiply that here as well. Minus 3x plus 1 power minus 2. So this would be minus 3 upon 3x plus 1 square. And what does this become after simplification? This goes here. It's a upon b by c. So it's going to be a divided by b upon c. So A times C upon B. So these two get multiplied. So we get 3x plus 1. And then after simplification, it's minus 3 upon 3x plus 1. This was a pretty lengthier approach. There's a way more straightforward way of doing this question. उस पे भी बात करते हैं. We could use the property of log. You remember the property ln A upon B? If we have a fraction inside the log, what is ln A upon B equals to? If you have ln A upon B, then it can be written as ln A minus ln B. So I'm going to rewrite the question. Ln 1 over 3x plus 1 would be equals to ln 1 minus ln 3x plus 1. Remember what's ln 1? ln 1 is 0. So we get 0 minus ln 3x plus 1. And now we can derive this, and it's a lot simpler than what we did here. Also, you could use another strategy. You have ln 1 over 3x plus 1, which means you have ln bracket 3x plus 1 power minus 1. Now, from rule of log, that power can be written here minus 1 ln 3x plus 1. So, use this method or use this method and significantly simplify the structure of the question. Now, let's derivate this. What would be the derivative? We just have to use the log property, the differentiation on log, not any other property. Okay, so minus is still minus. Derivative of ln fx is 1 upon fx times the derivative of fx, which is 3. So we got the same answer as before with a lot less effort. Minus 3 upon 3x plus 1. All right. Another example. Y equals 3 ln x power minus 2. Okay. Again, instead of trying to solve it, instead of trying to differentiate it, let's first apply a property of log on this. There's a property of log that if you have ln x power a, it becomes a ln x. So we can bring this power down. It gets multiplied with 3 and we get minus 6. Now we can derive this. So it's going to be dy over dx. Minus 6 is still minus 6. And the derivative of ln x is 1 over x. It's minus 6 upon x. Another example. Y equals ln bracket 2x plus 1 upon 3x minus 1. Now, instead of trying to derivate it, let's first apply property of log, which is ln A upon B equals ln A minus ln B. So, y equals ln 2x plus 1 minus ln 3x minus 1. Okay. Now we're going to apply the rule for derivating ln fx, which is when we derivate this, it becomes 1 over fx times f prime x. Okay. So y equals 1 over 2x plus 1 multiplied by the derivative of this, which is 2. Then a negative sign, 1 over 3x minus 1 multiplied by the derivative of this, which is 3. Two over 2x plus 1 minus 3 over 3x minus 1, y equals to, sorry, dy over dx equals to this. I should have written dy over dx here as well. So this would be the answer. Again, just like yesterday, there would be seldom a case when you'll just be asked to differentiate uh, ln fx. Instead, you'll be asked to find equation of the tangent, equation of the normal, stationary point, or determine the nature of the stationary point. So now let's take a look at questions like that. Find the equation of the tangent to the curve. Y equals ln 2x at x is equals to half. So we have to find the equation of tangent. So there's a curve ln 2x and you have to find equation of tangent at x equals to half. So we start by derivating it. Dy over dx would be 1 upon fx, which is 2x, times the derivative of this, which is 2. So that's just 1 upon x. And we'll get the gradient, the slope, by substituting this half here. So 1 upon half is 2. So the slope of the tangent is 2. So now y equals 2x plus c would be the equation of the tangent, but we need to state the value of c. For that, I need an x comma y. The x is half and the y would be substitute half in the given equation, ln 2 into half, which is ln 1, and ln 1 is actually 0. So it's going to be half comma 0. So substitute half comma 0 here. 0 equals 2 times half plus c. So c equals minus 1. So the equation of the tangent is y is equals to 2x minus 1. Or you could have also used this. Y minus y1 equals m x minus x1. So y minus 0 is equals to 2 bracket x minus half. That would have worked as well, unless the question had said give the answer in the form of y is equals to mx plus c. Then only this answer would get you the full marks. Okay. Another question. Find the equation of the tangent to the curve. In the equation tangent to the curve y is equals to ln 3x at x is equals to e. Okay. The same strategy. Start with derivating it. Dy over dx equals 1 over fx first, so 1 over 3x times derivative of 3x, which is 3. So we get 1 over x. So now the slope would be 1 upon e, that's the slope of the tangent. So y minus y1 is equals to m 1 over e times x minus x1. However, I need a value of x and y. X is e, y would be y equals ln 3e. So ln 3e is y. So y minus ln 3e equals 1 over e times x minus e. Either this or in the form of y is equals to mx. Moving on. Find the coordinates of the stationary points. Acha, in such questions, the examples we did just now, they could have also asked for equation of normal. So equation of normal may, how do things change? The gradient just changes. So instead of 2, 2 is the equation of the normal. Let's say the sketch, for example, looks like this. For example, it looks like this. So if this is the tangent, the derivative always gives you the slope of the tangent, which was 2. So then if the question is asking for the slope of the normal, then the slope would have been minus half, the negative reciprocal of the slope of the tangent. And then the point is still the same. So you have an x comma y, you can use the equation y is equals to mx plus c. So the slope is the negative reciprocal of what we've just found if the question was asking for the equation of the normal instead of the equation of the tangent. Find the coordinates of the stationary points. If any will cover. For y equals half x squared minus ln 2x. Okay. For the stationary point, dy over dx is equals to 0. So let's derivate that. Dy over dx would be 2 comes down, 2 and 2 cancel out, and we have x power 1 minus, it's 1 upon fx times the derivative of fx, which is 2. So dy over dx equals x minus 1 upon x. Now let's substitute, let's equate it to 0 and solve this and get a value of x and put it back in the original equation and get the corresponding value of y. That would be the coordinates of the stationary point. So take LCM, x square minus 1 upon x is equals to 0. So x square minus 1 is equals to 0. So x square equals to 1. X is equals to square root of 1. So x equals plus minus. So when x is 1 and when x is minus 1, you'll have two different values of y. For the first one, it's y equals half times 1 square minus ln 2. So that's going to be half minus ln 2. So the first coordinate of stationary point is 1, comma, half minus ln 2. And for x is equals to minus 1, y would be equals to half minus 1 whole square minus ln minus 2. However, this gives you math error because you cannot give an negative input to log. So the answer would be no solution here. There is no stationary point at x is equals to minus 1. So this would be your only stationary point. Same question, different equation. Find the coordinates of stationary point if any for y equals x square minus ln x square. First, I'm going to apply property of log and simplify this slightly. I'll get y is equals to x square minus 2 ln x. Derivate this dy over dx is 2x minus 2. Derivative of ln x is just 1 over x. So we get 2x minus 2 upon x, and we must equate it to 0 to find coordinates of the stationary points. So we get 2x square minus 2 upon x is equals to 0. So we have 2x square minus 2 is equals to 0. 2 can be taken common, x square minus 1 is equals to 0. And same as last time, we get x is equals to plus minus 1. Now, when x is 1, y would be 1 square, which is 1 minus ln 1. And you must know that ln 1 is 0. So y is 1. So we get 1 comma 1 as our first stationary point. For the second stationary point, we get x equals to minus. Now you have to be a little careful in such questions. These questions are designed to make you guys lose marks. Now, if you substitute minus here, minus 1 here, then you will get a value of y. Value of y de dega calculator. However, if you notice that x is also an input of log. An input of log cannot be negative. बल्कि नहीं आएगा. Even with that, we won't get an answer. Hold on. Yes, we won't get an answer for y even if we use this, because we'll get y equals minus 1 whole square minus 2 ln minus 1. So there will be no solution. However, if you try substituting it here mentally without using a calculator, you might end up with a solution. You'll say that once minus 1 square is 1, and then minus ln 1 square is also 1. And this gives you 1. And you will say that the second stationary point is minus 1 comma 1. This would make you lose marks. This will get your marks deducted. The reason is logs argument or log input can never be negative, whether there's a square on it or not. Try entering this in your calculator. In your calculator, enter minus 1 whole square minus ln minus 1 whole square. It will still give you a math error. Enter minus 1 whole square minus ln and then minus 1 whole square. So we might think that this becomes positive and you will get ln1, which is 0, but it's not the case. Whether there's a square on it or a cube on it or whatever, the input fed to a log function, natural log function or log function cannot be negative. That's all about case number 2. I think we should end it here, and inshallah on Monday we'll start the third case, which is differentiation of sin x, cos x, and tan x and their variations. ठीक है, वो Monday से start करेंगे. Your homework for the weekend is go over everything I've done in the last 2 classes, because if you don't keep revisiting these topics, आगे जाते जाते पिछला सारा भूलता जाता है. So please, it's your responsibility to keep this in your mind. ठीक है, कल मिलते हैं. कल नहीं, इंशाल्लाह मंडे को मिलते हैं. बाय बाय, टेक केयर, अल्लाह हाफिज.